Hello everyone. In this video, let us learn how to compare the starting and running winding currents of a capacitor run motor at various loads and measure the speed. At the end of this video, you will be able to
measure the current in each winding at a given load condition. Load the motor to a specified load. Let us collect the tools, equipment and machinery required for this practical. Electrician's toolkit, moving iron ammeter, tachometer, capacitor run motor, brake load arrangement, single pole knife switches, connecting cable as required, measure. Let us discuss main winding and starting winding. The main winding is designed with low electrical resistance and high inductance. This combination allows it to carry the main current efficiently while creating a strong rotating magnetic field when connected to the AC power supply. The main winding is stationary, meaning it doesn't move. It's fixed in the stator of the motor and surrounds the rotor. When the AC current flows through the main winding, it generates a rotating magnetic field. This magnetic field is essential for inducing currents in the rotor and causing it to rotate. The main winding remains active throughout the operation of the motor. Once the motor starts and reaches its rated speed, the main winding keeps producing the rotating magnetic field that keeps the motor running. The starting winding is designed with higher electrical resistance and lower inductance compared to the main winding. This combination creates a phase difference between the magnetic fields of the main and starting windings, which is crucial for initiating the motor's rotation during the starting process. The starting winding is usually physically displaced from the main winding to achieve the required phase shift between the magnetic fields. This displacement can be achieved either by placing the winding at a different angle or using different slots in the stator. The starting winding is active only during the starting phase of the motor. It provides the necessary starting torque to overcome the motor's inertia and get it spinning. The starting winding's design provides a higher starting torque compared to the main winding, which is crucial to overcome the initial resistance and get the motor moving. By combining the unique characteristics of both the main winding and starting winding, a single-phase induction motor can efficiently start and sustain its rotation, making it suitable for various applications in homes and small industries. Connect, run and measure starting and running current, speed of AC single-phase capacitor run motor. Identify the terminals of starting winding and running winding. Set the ohm meter to the lowest resistance range. Measure the resistance between the terminals. The main winding should have a lower resistance value, typically a few ohms, compared to the starting winding, which usually has a high resistance value, several tens of ohms. Insulation resistance test. Ensure the motor is disconnected from the power supply. Use an insulation resistance tester, say a measure, to measure the insulation resistance of each winding. The main winding should have higher insulation resistance compared to the starting winding. Select the ammeter range suitable to the motor under test. Connect the circuit with brake load arrangement. Connect the single pole knife switches S2, S3 and S4. Start the motor on no load and open the switch S2, S3 and S4 after the motor attains the rated speed. Read and record the ammeter, measure the speed and record in tabulation. Adjust load until A3 reads half full load current. Record the currents in each winding in tabulation. Record the ammeter's reading and speed at full load. Conclusion: the winding that draws less current is likely the main winding. The main winding generally has the lower resistance, resulting in the lower current consumption during normal operation. The winding that draws more current is likely to be the starting winding due to its high resistance characteristics.
This concludes the exercise on how to compare the starting and running winding currents of a capacitor run motor at various loads and measure the speed. Hope now you will be able to
Measure the current in each winding at a given load condition. Load the motor to a specified load.
Thank you. See you in next exercise.